and in this session I am going to discuss about the DMA controller, features of the DMA controller, operations of the DMA controller, and why we need the DMA controller. So let us start with the direct memory access, the DMA controller. So the direct memory access controller. What is the need of direct memory access controller? In simple terms, if you want to perform an high-speed data transmission with memory and the peripheral devices, basically we will make use of a special circuit called the DMA. So the DMA controller is used for achieving high-speed data transmission with respect to the memory and the peripheral devices. So the definition of an DMA controller is the direct memory access controller is an external device that controls the transfer of data between input-output devices and the memory without the involvement of the microprocessor. Means we will make use of the microprocessor, but it will not involve the data in the data transmission. So the each and every piece of data transfer will be done with the help of the DMA controller. So why we will take the support from the DMA controller? So I'll discuss that also in this session. So it holds the ability to directly access the main memory for read or write operation. Basically, it is designed by an Intel to have the fastest data transfer rate with less processor utilization. So as we know, in order to execute an operation, the microprocessor first fetches the instruction and then decodes it and then executes it, which are the three phases of the instruction processing or instruction execution: fetch, decode, and execute. But individually, if the microprocessor is taking care about all these three activities, so it will take a lot of time to perform the task. So that's the reason what we are doing. We are going to enhance the performance of the processor by adding an external device. So wherein that device we are calling it as an DMA controller, which is used for or which is able to manage the data transfer operation between peripherals and the memory within the less utilization of the CPU. So basically, it is nothing but hardware controlled data transfer, where the data address and control signals required for transferring the data is generated by an external device. So this method of transfer is known as direct memory access, and the external device used for this purpose is called as an DMA controller. So I hope you understood what I said. So the DMA controller in simple terms, which is used for performing an high-speed data transmission with peripheral to the memory, wherein the less utilization of the CPU. Then why we need it? Why we need the DMA controller? We know that generally whenever there exists a need for transfer of the data between peripherals and the main memory, then first the data is given to the processor by the input device, and the processor further transfer the data to the memory. So, and at the time of the data transfer, the processor cannot perform any operation and it cannot execute any instruction. So hence, when the system has a DMA controller, then it frees the CPU from data transfer operation, and at the particular time, the CPU can execute other operations. So this is the reason only we required an extra circuit called DMA controller, wherein the processor can do other activity while the DMA controller is performing the data transmission. Okay, so this is the main usage of the DMA controller, and we need the DMA controller. And what are the features of the DMA controller? As I already told, so the DMA controller definition is the DMA or direct memory access controller is an external device that controls the data transfer between IO device and the memory without the involvement of the microprocessor. So this is the usage of the DMA controller. And what are the features of the DMA controller? It is designed by the Intel Corp. It consists of 4 channels that can be utilized over 4 input and output devices simultaneously. And all of the 4 channels can be separately programmed, and all the 4 channels hold the 16-bit address and the 14-bit counters individually. If you are taking example of the one channel, the channel can consist of 16-bit address registers and the one 14-bit count register, and each and every channel is capable of transferring data up to 64 kilobytes. And the operating frequency ranges between the 250 Hz to 3 megahertz. So the three operations that are performed by each and every channel are the read transfer, write transfer, and the verify transfer. And we can operate this DMA controller in two modes of operation, that is master mode and the slave mode. So these are the typical features of the DMA controller, wherein it is designed by an Intel Corp and it is used for performing an high-speed data transmission with the help of the 4 channels which are programmed accordingly. And we'll see the basically how a DMA controller will work, or the operation of an DMA controller. As you are seeing on my screen here, we are having a operation of the DMA controller in a microprocessor system. We are having the microprocessor and the memory and the peripheral device. We are calling it as an disk controller as well, and the key role is taken by the DMA controller. So here we are having some of the signals which are related to the microprocessor hold and hold acknowledgement, wherein the 2 pins of the microprocessor of hold and hold acknowledgement are directly connected to the DMA controller. Whenever you want to perform a data transmission, so the DMA controller, whenever like we want to perform the data transmission, the peripheral device will issue a request to the DMA controller called DRQ. Whenever it receives the DRQ request from the peripheral device, the DMA controller will send one more request to the microprocessor, means hold request it will send. It is telling the microprocessor, I want to take control over the data bus, address bus, and control bus. So if you are okay for the data transmission, then you relinquish, means release all the buses, so that I can perform the data transmission with respect to the memory and the peripheral devices. If the microprocessor is able to give the permission, then at that time it will send a signal called hold acknowledgement. Whenever it receives a hold acknowledgement signal from the microprocessor, the DMA controller will give the one more signal to the peripheral device. So it will issue a signal called DMA acknowledgement, means the DMA controller is ready for transferring the data between the memory and the IO devices or the peripheral devices. So this is the simple operation of the DMA controller, wherein it acts as an interface between the peripheral and the microprocessor. So whenever the microprocessor releases, or whenever the microprocessor tells that the DMA controller with an hold acknowledgement signal, so the DMA controller is capable of taking control over all the buses like data bus, address bus, control bus, and it can perform an data transmission without the involvement of the microprocessor, because all the buses are under control of the DMA controller. So that's the reason the buses will be used for transferring the data without any interruption. So in this way, it is going to achieve an high-speed data transmission with respect to the memory and the peripheral devices. So I have covered what is DMA controller and why we need the DMA controller, and what are the typical features of the DMA controller, and the basic operation of the DMA controller in this session. And you can see some of the signals which are like related to input output read and input output write, and the memory read and the memory write. So wherein these are the signals which are related to the input output peripherals and the memory mapped IO. So memory mapped IO and the like input output we will have. So all these things I will discuss in the next session. So in the next session, I am going to cover the pin and the block diagram of the DMA controller.